All right, guys, let's get started. Study guide for the test, okay? So all these are going to require you to solve. And on the test, you're going to be expected to write out the factors and then the solutions, okay? So let's jump right in. Number 1, solve 5x cubed plus 5x squared minus 60x equals 0. Okay, so notice, since it has equals 0, that means we have to solve for all the values of x that would make this equation true. And the values of x that would make this equation true would be any value that I plug in for x, that when I simplify everything, gives me 0. Okay? Alright, so notice here, I have a trinomial, and all these have an x in common, but not only that, that's a multiple of 5, that's a multiple of 5, and so is 60, a multiple of 5. Remember, a multiple of 5 is any number that ends in 5 or 0. So for example, 5, 10, 15, 20, 25, 30, 35, and so on, okay? So all these can be divided by 5 as well. So I can factor out a 5x here. And so what am I left with? Well, I am left with, let's see here. If I divide out of 5 here, I'm left with an x squared plus, notice here, it's like if I'm backwards distributing or undistributing. So 5x times x squared is 5x cubed. Now 5x times what is 5x squared? Well, just x. Notice 5x times x is 5x squared. Minus, I need a negative because I'm going to multiply 5 times some number to get negative 60. And that answer is negative 12. Okay, so 5x times negative 12 will give me the negative 60x. Okay, so now I still have a trinomial in here. Let's go ahead and try to factor that. So this remains here, 5x, and then I'm going to try to factor this. So split the x squared into x times x, and then I need a negative 12 here. And so I want to get two numbers that multiply to make negative 12, so I could try negative 6 and 2, right? But I need a positive 1 here. So if I subtract these, I'll get a positive 4 here. So that's not what I want. So let's try 4 and 3. 4 times 3 is 12, good. But I need a 1 when I subtract. So it's going to have to be the 3 that's negative. So 4 minus 3 is 1. Okay, so I'm going to put plus 4 minus 3. Okay, now the factors, remember on the practice test, the factors are just these right here, the 5x, the x plus 4, and the x minus 3. So those are my 3 factors, okay? So my solutions from these are just going to be the values of x that make this equal to 0. Since they're all linear, meaning it's just x to the first, x to the first, x to the first, my solution for that one's going to be 3. My solution from that one's going to be negative 4. And my solution from that one's just going to be 0. Remember, when it's x just by itself, in this case it's 5 times x. 5 times what is 0? Well, 0. 5 times 0 is 0. Okay? So these would be called my roots or solutions. Okay, I'll just put apostrophe s there. Or zeros. All these would be answers that would be called either roots, solutions, or zeros, okay? And the factors are these, 1, 2, 3, without the x, without the equal 0. Keep that in mind for the test, okay? So these are my factors here. I'll just put a box around them. And these are my roots, solutions, zeros, whatever you want to call it, okay? Next one, we're going to do the same thing for all of these, okay? We're going to write the factors and then the roots. Okay, notice here I have a trinomial again. So I'm going to go ahead and try, I'm going to jump straight into trying to factor it like this. 2 parentheses or 2 factors multiply together. So here I'm going to go with 6 times 4, 6x times 4x. That gives me the 24x that I need right here. And 1 is easy, it's just 1 times 1, 1 times 1. Okay? Now notice I need a positive 10 here. Okay, so let's make both of these positive. And then let's see if this works. 4x times 1 is 4x, and then 6x times 1 is 6x. Doesn't that give me 10x? Yes, it does. Okay, now if I would have started with 12 and 2, this would not have worked because I would have gotten 12x and 2x. That would have been 14x, so I need a 10x. So 4 and 6 were the correct ones, okay? So notice I'm done factoring. So that means that these here are going to be my factors, okay? But let's go ahead and solve for each of these here. So remember, just take the opposite of that number, so that's a negative 1, and then put it over 6. So that's one of my solutions. And then do the same thing for this one. Take the opposite of that one, that's negative 1, and then put it over that number, 4. Okay? So these are my roots, or solutions, or zeros. Okay? And then these are my factors right here. So my factors are 6x plus 1 and 4x plus 1. And then my roots or solutions or zeros are negative 1 over 6 and negative 1/4. Again, what does that mean? Well, it means that if we were to plug these in here, right, one at a time, negative 1/6 here and negative 1/6 there, simplify everything, we would end up with 0. Okay? All right. Next problem. Solve. Okay? So we have 4 terms here. So whenever we have 4 terms, we want to try factoring by grouping. Okay, so let's go ahead and factor here. This first group here, I could factor out an x squared. And that leaves me with x plus 5. Notice if I distribute, I end up with that. Okay, now whenever the next set of terms here starts with a negative, you want to factor out a negative. And notice here, what can I factor out of the 7 and the 35? A 7. Okay, so I'm left with x. Now, negative 7 times 5, positive 5, is going to give me negative 35, okay? So here I have, it worked out, factoring by grouping. So I'm going to go ahead and put x squared minus 7 together in one, and then x plus 5 in the other one. Notice these are my two factors. I have a linear and a quadratic factor, okay? Now notice this is not a difference of squares, so I cannot just factor further. But this here is linear, so I could just get a factor from there. That's going to be negative 5, okay? But what about this one? Okay, what we're going to do here is we're going to solve for x. So we're going to set it equal to 0. So x squared minus 7 equals 0. Add 7 to both sides. And we get x squared equals 7. Okay? Square root both sides, and I get x equals, notice I cannot simplify this, so it'll be plus or minus square root of 7. So, plus or minus square root of 7. Now, keep in mind that this is a total of 3 solutions, positive square root of 7 and negative square root of 7, and then negative 5. So that's 1, 2, 3. Notice here the degree is 3. So my factors are these here. Those are my factors. And then these are my roots, 1, 2, 3. Okay, done. Number 4, solve. F of x equals x plus 2 times x squared minus 5 times 3x plus 1. The nice thing about this is it's already factored for us. Okay, so it's this times that times that. Those are factors. Okay, factors are things that multiply together. So here we have a solution here. So this is linear, so it's just going to be negative 2. X squared minus 5. It's going to be a plus or minus answer there. I'll just put that first. Next, I have 3x plus 1. That's going to be negative 1, the opposite of that, and then over 3. Okay, so now let's solve this one here. X squared minus 5 equals 0. It's kind of like the one I did up here. Okay, and so let's add 5 to both sides. I get x squared equals 5. X equals, and then there's a plus or minus square root of 5. So there's plus or minus square root of 5. Okay, notice how many roots I have. I have 1, 2, 3, 4. 4 total. Okay, all right, and those already are in factored form, so no extra work there. Look, this is in standard form, so like all the other ones that we've done, except for this one, we have to factor. Okay, notice it's a trinomial, and then this is to the 4th power. This is half of that, so that means we can factor using this method here. So let's split this up, x squared and x squared. And now I need to split up the 50 there. I need to multiply two numbers to make 50, but at the same time, they need to add up to 27. Well, let's see, 10 times 5 is 50. But if I add them, I get 15, so that's not going to work out. What else makes 50? I'm thinking here. 50, 50, 50. 25 times 2. There you go, 25 times 2. 25 plus 2 is 27. There you go. Now I need negative 27. So let's make both of these negative. and that'll still give me a positive 50 if I multiply. So minus 25 minus 2. Oh, what do you know? We have a difference of squares there. So that's going to factor out into two more factors. So we get x times x, right? And then positive 5 and negative 5. And this one stays as is. Okay? So my two linear roots are going to be here negative 5 here and positive 5, right? What about for this one? Just solve on the side. X squared minus 2 equals 0. Let's go ahead and add 2 to both sides. I get x squared equals 2 square root both sides. I get x equals plus or minus square root of 2. Remember, these always come in pairs, so plus or minus square root of 2. So I have 4 roots, 1, 2, 3, 4, and these are my factors right here. So factors and roots. All right, 3 more to go. Okay, solve again. Let's look and see how many we have. We have 3, so that means we're going to try to use that trinomial method. But first, let's see if they have anything in common. They do. They have x squared in common. Notice they all have x, at least 2 x's. So this will leave me with x to the 4th minus 3x squared minus 10. Okay, so this one's like the one we just finished doing, where we had x to the 4th and x squared, right? So that's what we have inside the parentheses there. Let's go ahead and factor this here. So we're going to go ahead and split up that one. Okay, and keep in mind this won't always work, but it just will happen to work in this example. So this will be x squared times x squared. And I need a negative 10 there when I multiply, and a negative 3 when I add. So that's going to be 5 times 2. Notice if I subtract 5 and 2, I get 3. But let's make the 5 negative. So minus 5 and plus 2. Okay? So notice when it's just x squared by itself, you're going to end up with 2 zeros. So 0 and 0, because there's 2 x's. So I get 2 zeros. For this one, x squared minus 5, let's just do it right here. X squared minus 5 equals 0. Add 5. And I get x squared equals 5, square root both sides. That's going to be a plus or minus square root of 5. So from this one, I get plus or minus square root of 5. Okay? What about this one here? I'll do it off to the side right here. X squared plus 2 equals 0. So we're going to go ahead and subtract 2 on both sides. I get x squared equals negative 2. Square root both sides. We end up with a negative inside the radicals. So that's going to leave us with an imaginary solution. But this 2 won't be able to come out, so it'll just be plus or minus I radical 2. So here we go, plus or minus I radical 2. So notice a 6 up here means we should have 6 solutions. So we have 1, 2, 3, 4, 5, 6. Okay. All right. Last ones here should be pretty easy. Write a polynomial. So we're going to write a polynomial here of degree 3 in standard form with the following roots. Okay. So it's got to be degree 3. That means it's got to be x to the 3rd power. And it's got to be in standard form. This is standard form right here, okay? So that means we have to multiply everything out. So notice here I need a degree 3, so that means I should have 3 roots. But notice here I only have 2 roots. Well, you should know by now one of them is missing. Remember which one of these comes in pairs? The 6 or the radical 3? Well, the radical 3, right? We're missing the negative radical 3. Okay? So now that I have all 3 roots accounted for, I can go ahead and write my equation like this. And you could always use f of x or y equals. I'll use f of x. Okay? But let's just go ahead and put our 3 factors. 1, 2, 3. And then this will be x minus 6, right? We're doing it in reverse. This will be x minus square root of 3. And then x plus square root of 3. Okay? We're not putting it equals 0. Okay? We're putting f of x equals. You can put x equals 0, by the way. So we're going to go ahead now and multiply these two here. And so that'll be x times x is x squared. And then multiply these here. That'll be negative square root of 9. Right? Let me bring everything else down. X minus 6. Okay? And then here I'm going to go ahead and simplify that. What's the square root of 3? Well, the square root of 3 is 3. Okay, so I just simplified it one more step there. Let's keep going. Let's multiply all this out now. Okay, so I'm going to do the box method here off to the side. So that's x minus 6 and then x squared minus 3. X cubed minus 6x squared minus 3x and then plus 18, right? And that's it. So it's going to be x cubed minus 6x squared minus 3x plus 18. F of x equals. Now, would it be wrong if you said x cubed minus 6x squared minus 3x plus 18 equals 0 instead? Not at all. In fact, feel free to do that, okay? So, that's it. This is a standard form. Standard form means we write it from least to greatest with the highest degree going first, right? And so, just write it out in standard form and you're done, okay? I'm double checking, making sure I didn't make any mistakes. Okay, now the last one, we save the easiest for last. And it's this one here. Write a polynomial of degree 4, so to the 4th power, right? In factored form. That's what makes this one easy, because it's just going to be written in factored form. No multiplying out necessary, okay? But again, it's with the following roots, and they leave one out on purpose. It's 3i, 1, and 5. So which one's missing if we need 4 roots, right? Well, the imaginary is missing. We need to put a negative 3i. Okay? And factored form, this is all we have to do here. F of x equals, and we put 4 factors. And then we're not going to go beyond this step, right? Once we fill in the parentheses, that's it. So I'll just start with the constants first here. Sorry, not the constants, but the real number roots. It'll be x minus 1, x minus 5, and then x minus 3i, and then x plus 3i. Okay? You can multiply this out if you wish, just so that it's not in imaginary form. And it would look like this, x minus 1 times x minus 5. And then you just multiply this out, that'll be x squared minus, now remember, negative 3i times positive 3i, that's going to be, I'll do it over here, that's going to be negative 9i squared, right? But what's I squared? Well, that's negative 1. And so what's negative 1 times negative 9? Oh, that's positive 9. So we can actually just write it like this. Okay? So on the test, I wonder whether it'll be given this form and that form. I'll tell you guys on the day of the test, okay? But for now, just know that both ways are possible answers. And that's it.